Kenji was a master of composites, a true artist of carbon fiber. His small, specialized shop in Florida was renowned for repairing crash damage on multi-million-dollar hypercars, work the manufacturers often deemed impossible. His latest acquisition was an insurer's worst nightmare, a McLaren Senna, retrieved after a devastating Category 5 hurricane. The car, originally a vibrant papaya orange, was found lodged beneath the remains of a collapsed coastal garage, having been submerged in a chaotic mix of saltwater, sand, and debris for over a week. The Senna's value was immense, but its condition was catastrophic. The carbon fiber monocoque chassis, the very core of the car's strength, was intact but showed hairline stress fractures from the structural impact. The entire suspension, the intricate aerodynamics, and the engine were saturated with corrosive salt water. This wasn't corrosion. It was a physical and chemical assault on pure engineering. The initial estimate from McLaren was an immediate write-off due to the risk to the monocoque integrity. Kenji refused the easy path. He saw the challenge. The restoration wasn't just fixing a car. It was a mission to save a piece of automotive perfection. The first phase, similar to naval salvage, was the complete neutralization of the salt. He spent days methodically washing the car with deionized water, attempting to purge the microscopic salt crystals from every weave of the carbon fiber structure. The engine, the twin-turbo V8, was immediately flushed and placed in a vacuum drying chamber to halt corrosion. The first major challenge emerged in the vehicle's unique active aero system. The complex hydraulic actuators governing the massive rear wing and the front blade system were seized by sand and salt. Kenji realized the key to the entire restoration lay in reviving these systems without destroying the delicate carbon veins. He found a single non-factory modification, a small, hidden USB stick taped inside the fuse box, placed there by the owner. The drive contained not crypto, but the original CAD schematics for the Senna's bespoke hydraulic lines and a note: "Trust the pressure calibration." This gave Kenji the engineering blueprint he needed to begin the meticulous disassembly. The true drama lay beneath the damaged shell, the monocage 3R chassis. The carbon tub had survived, but the insurer's main concern, the hidden stress fractures, was real. To certify the chassis for track use, Kenji couldn't simply patch it. He had to perform a full structural scan and repair the individual carbon layers. This required an aerospace-grade ultrasonic phased array testing (PAT) machine. The process involved injecting specialized resin into the microscopic fractures, then curing them in a custom-built, low-temperature autoclave. This painstaking process took 6 weeks, ensuring the tub's stiffness and safety met the impossible standards of the original construction. Simultaneously, the engine restoration was a race against time. The V8 had to be stripped down to the block. The aluminum components were pitted, and the complex, bespoke turbochargers, designed for zero-lag performance, were choked with sand. Kenji and his engine specialist, Maria, rebuilt the turbos completely, hand-polishing the vanes and replacing every single bearing and seal with aerospace-grade materials. The V8 was brought back to life, not just repaired, but re-engineered for longevity against corrosion. The most complex task was the active aero hydraulic system. The salt had damaged the microscopic internal valves and pumps. Kenji used the recovered CAD files to meticulously rebuild the entire hydraulic pump assembly, recalibrating the pressure valves to the owner's specific track settings detailed in the schematics. This was the moment where the restoration specialist transcended the role of mechanic, becoming a true reverse engineer. The restoration was not just about fixing the car. It was about honoring the legacy of Este Senna, the precision, the refusal to compromise, and the pursuit of engineering perfection. Kenji and Maria were not just restoring a car, they were restoring a philosophy. Hold on tight. This McLaren Senna is being rebuilt from the absolute brink. We're talking individual carbon fibers and microscopic hydraulic pumps. Kenji is proving that human skill can overcome a Category 5 hurricane. You can't miss the final assembly. Hit that subscribe button right now and give this video a like. We're about to tackle the electronic brain and the final track test. Comment below. What's the hardest part of the Senna to restore? Let's get back to the impossible rebuild. With the structure and engine restored, the final hurdle was the brain, the vehicle control units, VCUs. Salt water had corrupted every major ECU, turning the sophisticated wiring loom into a tangled mess of broken circuits. The Senna's complex telematics, the interface between the driver and the machine, was entirely dark. The manufacturer deemed all VCUs irreplaceable due to the proprietary encryption required for the active aero and the adaptive suspension. Kenji refused to accept defeat. He sourced salvaged VCUs from non-water damage sources and spent weeks bench testing them. The major challenge was getting the car to recognize the new components and accept the original digital identity, the VIN. The car's security system was designed to instantly brick any non-matching part. Kenji, working with his electrical engineer, Anya, developed a highly precise, custom digital handshake protocol. Using a low-power laser, they carefully isolated the encrypted security chip, the IMMO chip, from the original water-damaged main VCU. They then meticulously transferred the encrypted identity key onto the new VCU board, bypassing the internal anti-tamper protocols. This was akin to performing digital microsurgery. The effort paid off. The dashboard flickered to life, showing the familiar papaya orange startup sequence. But the suspension systems immediately threw error codes. The digital system couldn't trust the newly rebuilt hydraulic actuators, seeing their ceramic seals as alien. Anya had to write a new piece of firmware, the purity of pressure protocol, that translated the new pressure signatures of Kenji's rebuilt ceramic components into the acceptable digital range expected by the VCU. This bespoke software, developed over 1,000 hours, was the final key to restoring the car's dynamic performance. The digital ghost of the Hurricane was finally exorcised. The exterior, which had been stripped, was finished in the original papaya orange, a meticulous, multi-stage paint job that brought the color back to a depth that defied its history. The massive, complex rear wing, now structurally repaired and hydraulically perfect, was reinstalled. The car looked flawless, but the ultimate test of the restoration was still to come: the track. The final phase was the track test. The owner, a professional endurance racer, demanded that the car perform precisely to its original factory specification. The test would focus on two critical areas: the structural integrity of the repaired monocoque under extreme lateral load, and the instantaneous, failure-free response of the rebuilt active aero system. Kenji and Maria supervised as the driver pushed the Senna to its absolute limit on a closed circuit. The car performed flawlessly. The monocoque held firm under 2G cornering. The custom rebuilt turbos delivered the full 789 horsepower. Most importantly, the active aero, the complex rear wing and front blades, responded instantly, adjusting pitch and angle in milliseconds, controlled by the purity of pressure protocol. The Senna was not just restored, it was functionally resurrected. The owner, ecstatic, not only paid the full massive restoration fee, totaling over $1.1 million USD for the specialized labor and parts, but awarded Kenji a permanent, open-ended contract for all future maintenance. The car, once written off as a total loss, was now arguably the most rigorously tested Senna in the world. Kenji's shop achieved global recognition. The restoration of the Hurricane Senna became a legend in the hypercar world, proving that a dedicated specialist could achieve what the factory deemed impossible. The reward was not just financial, it was the establishment of a global reputation built on uncompromising precision. Kenji kept one small memento: a tiny piece of the original salt-pitted carbon fiber from the rear fender, a reminder of the destructive power of nature and the resilience of engineering. The story of the Senna's storm surge resurrection proves that true perfection is achieved not by building once, but by rebuilding flawlessly. For Kenji, the master of composites, the legacy wasn't in the car's speed, but in the purity of its survival. If you want to uncover more stories of impossible restorations and automotive miracles, make sure you hit that subscribe button now and join us for the next great find.